The maintenance procedure for any transformer includes the following guidelines. First screen. Oil. 1. Oil level checking must be done and leakages must be attended. 2. Oil PDV and acidity checking should be done at regular intervals. If acidity is between 0.5 to 1 mg/kOH, oil should be kept under observation. 3. PDV, color and smell of oil are indicative. 4. Sludge, dust, dirt, moisture can be removed by filtration. 5. Oil when topped up shall be of the same make. It may lead to sludge formation and acidic contents. 6. Insulation resistance of the transformer should be checked once in 6 months. 7. Megger values along with oil values indicate the condition of transformer. 8. Periodic dissolved gas analysis can be carried out. Bushings. 1. Bushings should be cleaned and inspected for any cracks. 2. Dust and dirt deposition, salt or chemical deposition, cement or acid fumes depositions should be carefully noted and rectified. Breather. Periodic checking of any loose connections of the terminations of HV and LV side must be done. Breather examination or dehydration of silica gel must be done if necessary. Explosion vent. Explosion vent diaphragm examination is also important. Conservator. Conservator must be cleaned from the inside after every 3 years. OTI and WTI. Regular inspection of oil and winding temperature meter readings must be done. Cleanliness in the substation yard must be done with all nets, vines, shrubs removed. The best way of protecting a transformer is to have good preventive maintenance schedule. The maintenance schedule includes taking care of oil temperature indicators, winding temperature indicators, Foucault's relay, magnetic oil level gauge, explosion vent, HT fuse and TO fuse, LT circuit breaker, HT circuit breaker with overload, earth fault relay tripping, oil surge relay for OLTC, PRV for OLTC, horn gaps and lightning arrestor, breather. Now that we know the measures for protecting the transformers, let's take a look at the failures that can take place in a transformer. Insufficient oil level, seepage of water in oil, prolonged overloading, single phase loading, unbalanced loading, faulty termination, improper sized lugs, etc. Power theft, prolonged short circuit, faulty operation of tap changer switch, lack of installation checks, faulty design, poor workmanship, improper formation of core, improper core bolt insulation, burr to the lamination blades, improper bracing of joints, burr or sharp edges to the winding conductor, incomplete drying, bad insulation covering, insufficient cooling ducts in the winding, bad quality of raw material, transit damaged transformers. After failure, transformer is removed and replaced with new or repaired one without removing the cause of failure, which results in immediate or short time failure. Let us now look at the causes of these failures. Environment, system, maloperation, wrong design, manufacture, material, maintenance. The transformer failures can be classified as external failures and internal failures. They are as follows. Internal failure causes winding and terminal faults, core faults, on-load tap changer faults, overheating faults. External failure causes abnormal operation condition, sustained or unclear faults.
Let's look at the fault current distribution. Let's first understand earth fault on transformer winding.
Click the zoom icon to view the diagram.
The basic protection of transformers can be done in 4 different ways. Differential, restricted earth fault, overfluxing, overcurrent and earth fault.
Let's deep dive into 3 main types of protection. Differential protection, restricted earth fault protection, combined differential and restricted earth fault protection. Click each to know more. Click each to know more. Differential protection works on the principle of Moore's price current comparison. In this case, only relays with bias characteristic should be used. It is only applied where protection coordination is difficult or not possible using time-delayed elements. For fast fault clearance. For zone of protection. There are several considerations for applying differential protection. These include phase correction, filtering of zero sequence currents, ratio correction, magnetizing inrush during energization, overfluxing. The principle behind differential protection can be explained with the help of following circuit diagram, having an incoming feeder and an outgoing feeder. Click each image to view the enlarged version. Biased differential protection is preferred due to its fast operation, adjustable characteristic, high through-fault stability, CT ratio compensation, magnetizing inrush restraint, overfluxing fifth harmonic restraint. So, let's understand why this bias characteristic. Click each image to view the enlarged version. Click each restricted earth fault protection uses the high impedance principle. It has increased sensitivity for earth faults, REF elements for each transformer winding, CTs which may be shared with differential element. In REF, under normal conditions, the stability level is usually maximum through fault level of transformer. So, under normal conditions, no current flows through the relay, which means no operation. Let's understand the diagram in detail. On HV side, residual current of 3 line CTs is balanced against output current of CT in neutral conductor. For LV side, ground faults occurring on delta winding may also result in fault current of less than full load. HV overcurrent relays cannot provide adequate protection. Relay connected to monitor residual current will provide restricted ground fault protection since delta winding cannot supply zero sequence current to the system. Both windings can thus be protected separately with restricted ground fault protection. This provides high-speed protection against ground faults over whole of transformer windings. Here, the relay used is instantaneous high impedance type.
It is very much possible to combine both differential and restricted ground fault protections onto one set of line CTs, or in other words, by using interposing auxiliary CTs. This in turn saves expenses of providing separate cores for each protection systems. Congratulations! You have successfully completed this training module on transformers.